All right, so we're learning about simplifying with rational exponents. In order for us to do that, we first have to learn how to simplify roots. Okay, so what I'm about to show you is going to seem kind of weird, but it really is important. It's going to be important when we start getting into radicals that are not squared. Okay, so first of all, when we look at a radical, you know how we have those invisibles? Well, outside of every radical, there's an invisible too. So if you don't see a number out there, it's 2. And what that number tells you is how many times something has to be multiplied by itself before you can consider it that root. So this is a 2 root. So the 2 root of 4, since 2 times 2, what number times itself twice is that root? So I can take 2 of those outside. The 2 root of 4 is 2. Now the 2 root of 8 is going to be different. Again, seems kind of crazy. So let's look at question 1. Question 1, what I'm going to start with, and we're not going to do this every time, but I'm going to have you start with it like this. What you're going to do is you're going to expand this out completely. So I have x, 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 x. Then I have y, 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 y. Oh my gosh, y, y. 1, 2, 3, 4, 1, 2, 3, 4, y, 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 right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, awesome. So I've got x to the 4th, y to the 12th. Since this isn't a square root, that means I can group up 2 of these and take them outside the radical. When they come outside of the radical, it's like a 2-for-1 exchange. Okay? So 2 inside is 1 outside. So I can take these 2, and then I've got another x. I take these 2. That turns into a y. These 2 turn into a y. These 2 turn into a y. You see what I'm doing here? Every pair, since this is a 2 root, every 2 become 1 on the outside. So the square root of x to the 4th, y to the 12th is x, x, y, 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 which simplifies to x squared, y to the 6th. So half of what was in there. Okay? Now let's pretend that this had been the cube root. So instead of, we had x to the 4th, y to the 12th, but we had a 3 out here. Okay? What that 3 is going to mean is that I have to have them 3 at a time to pull them out. Okay? So I would do the same thing I had here. Oh my gosh, I would have x, 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 y, 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 exactly, y, 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 y. I think that's 13. I think that's 12. I don't know. We're about to find out. And I would have to have 3 of them at a time. So these 3 can go out. But this one doesn't have a partner, so it can't leave. It's got to stay under the radical. So I have 3 y's. They come out because this is to the 3rd. This is a cube root. Okay? And I have these 3 y's. So basically, the root kind of gives you the exchange rate. It says every 3 inside here was worth 1 outside. So think of it like you're trading money. You're exchanging money with another country. Okay, you have a 3-to-1 exchange rate. So if I want it for 1 out here, I got to get 3. I have to take 3 from the inside. Now, remember, I still had this one underneath the radical, so it has to stay there. I can't get it out because it doesn't have enough partners for me to take it out. So I have x, y to the 4th, cube root of x. Okay, this is kind of crazy, right? All right, so let's try this one here. Okay, we'll try it together. So you can think of this also as like 2 separate ones. So if you want to, you can actually, instead of making one big long one, you can separate them out. So I could say the square root of 25, the square root of y to the 4th. Well, what's the square root of 25? Well, it's 5. The square root of y to the 4th, well, this is y, 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 y. And since it's a square root, I got to take them out 2 at a time. So it's 5y squared. All right. So that's the first part. That's the part with just simplifying radicals, and we'll do some more of this in class. This is the part that's actually an exponent rule. Okay. So when we look at this exponent, let's say I have x to the 3 over 2. Okay. The top part here is your exponent, and the bottom part here is called your index. The index is your root. So the index goes outside, the exponent stays inside. So the top stays as your exponent. The bottom becomes what kind of root you have. So if I looked at this one, I have 4x to the 4th. The exponent the top stays as the exponent, the bottom becomes the index, and it tells me what I'm taking them out as. So if I expand this, I have 4x to the fourth, 4x to the fourth, 4x to the fourth. Well, I can take these two 4x to the fourths out, and I have a 4x to the fourth on the outside, okay, because I had to take them out two at a time. My index tells me how many times I have to take it out. 4x to the fourth over here, I'm going to have to expand this. So I have 2 times x times x times x times x. I have a pair of 2's, a pair of x's, and a pair of x's. So that's going to be 2x squared. So that's what I have outside, and I have nothing left inside. So I have 8x to the sixth when I take it out from under there. Okay, we will do more of this in class. Don't freak out. But we will work on more of this in class.